Some of the smartest people on Earth disagree about aliens, not because they all believe flying saucers are visiting us, but because the real question is much darker. If intelligent life exists out there, what does it mean for us? In April 2010, physicist Stephen Hawking issued a public warning grounded in the cold mathematics of survival. He argued that actively sending signals into the vast cosmos is an existential risk. To explain this, Hawking pointed to Earth's own history, specifically the arrival of Christopher Columbus in the Americas. That encounter did not turn out well for the indigenous populations. In Hawking's view, a technologically superior visitor presents an immediate, dangerous power asymmetry. A civilization capable of crossing interstellar distances would possess energy-harnessing capabilities far outside our current comprehension. They might be nomadic, having depleted their home planet's resources, now searching to conquer and colonize whatever worlds they can reach. If a civilization can cross the stars, the gap between them and us might be bigger than the gap between humans and insects. To such an advanced intelligence, humanity might appear completely insignificant, unworthy of diplomatic relations or mutual respect. This perspective demands caution. It is a plea for planetary preservation and strategic silence, rather than a surrender to fear. We must look at our own history to see how intelligent life behaves when it encounters a weaker neighbor. Before we actively announce our presence to the universe, we have to consider the cost of being heard. On October 19, 2017, the Pan-STARRS telescope in Hawaii detected a faint speck of light moving at 26 kilometers per second. Its trajectory was hyperbolic, indicating an origin far beyond our sun's gravitational reach. This was Oumuamua, the first confirmed interstellar object ever observed. As astronomers tracked the visitor, they encountered a series of physical anomalies. It was highly elongated, tumbling through space with an estimated length-to-width ratio of 10:1. More puzzling still, as it rounded the sun, the object experienced a small but distinct non-gravitational acceleration. Yet deep imaging revealed no cometary tail, no dust, and no detectable outgassing. Harvard astrophysicist Avi Loeb proposed a controversial explanation. He calculated that the unexpected acceleration could be caused by solar radiation pressure pushing against a very thin, flat surface, effectively a light sail. Loeb suggested Oumuamua might be a piece of artificial technology, a defunct probe sent by an advanced civilization. Most scientists disagreed with him, but the controversy was not just about one object. It was about whether science is willing to ask uncomfortable questions. Mainstream researchers proposed natural mechanisms, suggesting Oumuamua could be a hydrogen iceberg, a nitrogen fragment, or a remnant of tidal disruption. However, each natural explanation struggled to fit all the observational data. The debate exposed a fundamental friction in modern astronomy: the boundary between conservative scientific skepticism and the willingness to investigate the seemingly impossible. In September 2023, NASA released its first major report on unidentified anomalous phenomena, or UAPs. The 16-member independent study team arrived at a definitive conclusion. There is no confirmed evidence that any unidentified anomalous phenomena observations are extraterrestrial, but the agency did not dismiss the phenomenon. Instead, they reframed the entire debate. For decades, sightings of strange objects in the sky have fueled wild speculation. To NASA, the problem is not a lack of unexplained events, but a critical lack of quality data. Most UAP sightings rely on accidental observations, civilian security cameras, or military pilots tracking targets through sensors not designed for scientific analysis. The resulting images are often blurry, low resolution, and incomplete. This is not a story of government secrecy or hidden truths. It is a limitation of measurement. Because our global sensor coverage is highly fragmented, and our instruments are tuned to track weather or conventional aircraft, anomalous events are often captured without vital context. Without clean, verifiable parameters like speed, altitude, and thermal output, scientists cannot run the equations necessary to identify them. NASA is not saying aliens are here, but NASA is saying something important. Bad data creates mystery, and mystery creates myths. When observations are poor, our minds fill in the gaps. A glare on a lens becomes a metallic sphere. A tracking artifact mimics physics-defying speed. In the absence of rigorous measurements, science steps back, leaving a vacuum for imagination to fill. To resolve the mystery, institutions must shift from sensationalism to systematic, empirical observation. The entire debate is governed by a foundational rule. Extraordinary claims require extraordinary evidence. In the search for life across the cosmos, anecdotal accounts and isolated anomalies are not enough. A strange object captured on a single camera or an eyewitness report from a trained pilot might be intriguing, but in the scientific community, they are starting points, not proof. Human observation is vulnerable to bias, optical illusions, and memory lapses, making even the most sincere testimonies unreliable under rigorous scrutiny. Science relies on a more demanding currency. It requires repeatable measurements recorded by well-calibrated independent sensors. It demands raw data that can be isolated, analyzed, and verified by external researchers who have no emotional investment in the outcome. Every extraordinary hypothesis must undergo the unforgiving filter of peer review, where experts actively try to dismantle the findings rather than confirm them. If an explanation cannot withstand this systematic deconstruction, it is discarded. Speculation can paint vivid pictures of cosmic visitors, but the universe operates on cold physical laws, not human desire. Without independent testing and verifiable parameters, we are left with stories instead of science. To separate genuine discovery from simple error, we must adhere to this unsentimental standard. Science does not care what sounds exciting. Science only cares what survives testing. In 1950, physicist Enrico Fermi sat with colleagues and asked a deceptively simple question: where is everybody? This question, formalized in the 1970s by astrophysicist Michael Hart, remains the ultimate puzzle of modern astronomy. Kepler data suggests that roughly 20% of Sun-like stars host Earth-sized planets in their habitable zones. In our galaxy alone, that means billions of potentially habitable worlds. Statistically, life should be common. Yet, when we point our telescopes at the sky, we find nothing but an unsettling, persistent quiet. Scientists have proposed several chilling hypotheses to explain this silence. Perhaps intelligent life is vanishingly rare, requiring a sequence of evolutionary miracles we have completely underestimated. Or perhaps technology itself is a trap. Civilizations might inevitably self-destruct through nuclear fire, climate collapse, or runaway technology before they ever develop the means to cross interstellar space. Others suggest that advanced societies are out there, but they deliberately choose to hide, practicing strategic stealth to avoid predatory neighbors. Or we are simply looking for the wrong clues, tuning our instruments to primitive radio signals while the rest of the cosmos communicates through channels we cannot yet detect. There is also the problem of time. Humanity has only possessed the technology to listen for a fraction of a century. We might be out of sync, arriving billions of years too early or too late, searching a graveyard of long-dead societies. Ultimately, the debate is not just about finding others. It is a mirror held up to our own future. The silence forces us to confront the possibility that intelligence is either a rare, precious spark to be guarded at all costs, or a fleeting, self-limiting anomaly. As we look out into the dark, we are left with the cold weight of the cosmos, waiting to see if we are indeed alone. In the end, the silent cosmos remains a mirror. Our fierce debates over alien life are not really about the stars, but about our own fragile future. As we listen to the dark, we are ultimately looking for ourselves. Share your thoughts in the comments.